This video is about Peltier module. Peltier module, a thermal control module that has both warming and cooling effects. By passing an electric current through the module, it is possible to change the surface temperature and keep it at the target temperature. Peltier, on the other hand, learned that passing current through two dissimilar electrical conductors caused heat to be either emitted or absorbed at the junction of the material. With modern techniques, we can now produce thermoelectric modules that deliver efficient solid-state heat pumping for both cooling and heating. Many of these units can also be used to generate DC power at a reduced efficiency. They offer precise temperature control and fast temperature response. Peltier module consists of conductive material on which are placed N-type and P-type semiconductors which have checkerboard pattern. At the top is ceramic substrate, capable of sub-ambient cooling, compact form factor and lightweight, high reliability due to solid-state construction with no moving parts, environmentally friendly, can be used for cooling or heating. It is ideal for situations where forced air cooling is not an option.
As always, we wanted to have some experience of what we learn, so we decided to make an experiment. Peltier module is mounted with thermal paste on the big heatsink to dissipate heat. But that big heatsink isn't still big enough, so there is also 12-volt fan mounted on the underside of it. For measuring the temperatures, we used two LM35 sensors connected to the hardware development board called Arduino, first on the cold side of the Peltier module and the second on the heatsink, which represents warm side of the Peltier module. After everything was connected as shown on the schematic, we started the measuring process. This is our simple program for changing voltage outputs of sensors to values of temperature. At the beginning, we need to make sure we have set correct port and Arduino board. Then we can compile and upload program to the board. Our goal is to get the info about temperatures from the Arduino to the graph. For that, we need to use some software which will save our informations to the text file. In our case, it is free software called CoolTerm. We need to set location of the text file which it will create and then connect to the Arduino. After successful connection, it starts to show temperatures and time of measuring. At this moment, I turned on the power supply and started increasing the current running to the Peltier module and fan. Here you can see how temperature 1 drops and temperature 2 slowly rises. At this moment, I put a drop of water on Peltier module, and after a few seconds it froze and around it created icing. Here I unplugged the fan from power supply so you can see how the temperature rises without active cooling. Here you can see the process of making graph from our text file. This is our completed graph. Horizontal axis represents time in seconds and vertical axis represents temperature in degrees Celsius. This is the point when I started recording the temperatures, but power source was disconnected, so the Peltier module had temperature of the surrounding air. Here I plugged the power supply and temperature of the cold side of the Peltier module started to decrease. From this point, the temperatures were slowly rising because of non-ideal cooling of warm side. From here, even faster, because I unplugged the fan, so you can see its function. But there was still constant difference between them because of the constant current running to the Peltier module until this point. Here I unplugged also the Peltier module from power source and the temperature started to equalize.
Applications of Peltier modules are in laser labs, in medical sector, and also in small refrigerator units thanks to its properties.